Hello, welcome back to Cracking the Cryptic, and a delight to be with you again, bringing you a second puzzle from Murdoch, a new planet who swam into our ken a week or more ago and has produced another puzzle with some X's in it. I'll have a look at this in a moment, and the rules and so on. I'm also going to mention, of course, that on Patreon you can have a go at Extra Byte, the Sudoku hunt featuring 5x5 puzzles, very popular. It's going very well, and thank you to the Skunk Works for preparing it and letting us feature it on our Patreon, where you can also see connections videos and difficult crossword solves. Now, what else is going on? We've got many things, actually. We've got all of our apps, which do feature Line Sudoku and Killer Sudoku, but also Fog of War, and now the worms, the fantastic worms, for instance, Michael Lefkowitz and Marty Sears, do try those. Other links under the video are to things like SVEN'S SUDOKU PAD on our website, and the catalogue of all our puzzles, and the Discord server connected with CTC and run by some brilliant moderators. And of course, on Mondays, often we are streaming our efforts at video games, and we love it when you join us for those as well. So loads going on, and an absolute pleasure to be able to bring it all to you, especially as you get to meet these new setters and learn about them. So Murdoch sent this one in, and the link under the video will take you to be able to play the puzzle. Murdoch has expressed the rules a little strangely, so do feel, in my opinion, and that's just me being probably very rude, but I'm going to explain the rules as I see them, which are that, what he has also done, if you can't read, because it will be quite small, especially on a phone, the box total, the cage totals, there is a list of them in the rule set as well, just because that may help. And that is a good thing, definitely, that Murdoch has done. Now, there are normal Sudoku rules. We're going to put 1 to 9 in every row, every column, and every 3x3 box. Each of the marked red diagonals in this case has no repeats, so they're each a set of the digits from 1 to 9. The box borders divide the blue lines into segments with the same sum. So that segment adds up to the same as that segment and that segment. That is very much how we like the blue line rule to be stated. White dots join two consecutive digits, and digits in a cage sum to the number or the value in the upper left corner of the cage. X is consistent for the whole puzzle. It doesn't actually specifically state that in the rules, but I think it's clear, and I think it's especially clear if you consider what would be the point of putting an X in the central cage if X wasn't going to be consistent for the whole puzzle. That would be a totally meaningless gesture. We have to determine the value of X for this puzzle as part of solving it. Murdoch goes to some extent to mention that it's not a negative number, but I don't think there was any way it could be, so I'm not really bothered about that. And as I say, then in the rules, if you call up the puzzle, there are some more details on what the cages say. This is x plus 3, this is 5x, 3x, x squared minus 3, x, 2x minus 1, x squared plus 6, x plus 5, x squared plus x. And that's all the rules we've got. So do give it a try. Murdoch's last puzzle was fun, had a bit of a sting in the tail, I felt. Let's see how this one goes. I'm going to restart the clock and say, let's get cracking. So, lots of blue lines, very few white dots. This blue line's interesting. These 3 digits have to be the same because there's only one of them in each box. Those 2 are the same. Those 2 are the same. Now, let's think about the X's. That's what I was putting off doing. So, if we look over here, x squared minus 3. Right, if x was 1, that would be 1 minus 3. That's no good. If x was 2, this cage would add up to 1. That won't work with Sudoku digits. So 1 and 2 are ruled out. 3 looks like it's possible. That would give a total of 6, 9 minus 3. 4 would give 16 minus 3 equals 13. That would have even more possibilities. And I think 5's too high. 5 squared minus 3 is 22. You can't do that in 2 Sudoku digits. So we've already established that x is either 3 or 4. Now this cage is therefore 9 or 12. Now, if x was 3, those would add up to 9, and that would add up to 6, and the pair of them would add up to 15 together. And you can just do that. That would be very helpful. Let's have a look at the other cages now. X squared plus x. If it was 3, that's worth 12. If it's 4, that's worth 20. X plus 3 is 6 or 7. Oh no, hang on, let's go back here. Let's go back to row 5. If x was 3, this cage adds up to 6. This cage adds up to 5. And those 4 cells would have to add up to 11. And 4 different cells that add up to 11 are always 1, 2, 3, 5. And that would then stop you putting the value of x3 in the middle. You'd have 2 3s in the row. So x is not 3, x is 4. And now we know the values of all the cages. We've got a 12 cage and a 13 cage, which is not 4 9 now. So it's either 5 8 or 6 7. This is a 7 cage, 2x minus 1, which is either 2 5 or 1 6. This one is 16 plus 6, that's 22. That always has a 9 in. It's either 9 8 5 or 9 7 6. Now that's quite interesting. We've used up the 5 and the 6. One of them's in that cage and one of them's in this cage. Let's just keep on looking at the cages. This adds up to 20 and it doesn't have a 4 in. X squared is 16 plus 4 is 20. So it doesn't have a 4 in. And it adds up to 20. It's not 974. It could be 983. Actually, there are some possibilities. This adds up to 7, same as this. So it's 1 2, 1 6 or 2 5. This adds up to 20. And this one 9. Might have, oh, and we can actually do a secret operation on this box, by which I mean an operation using the secret. The secret is the fact that we know the sum of every row, column and box in a Sudoku at the outset. It's always the same. It's always 45. So share that wisely. Now, if that cage adds up to 9 and this one adds up to 20, that's 29 between the two of them. Take that off 45 and you know this blue line now. This blue line adds up to 16. And the rule about the blue lines says that that adds up to 16, that adds up to 16, so those add up to 32. And this sort of de facto green cage adds up to 13 to make up the 45 total. Now these are quite middly numbers and not that helpful. Oh, I know the parity of this digit, because those two are 1 odd and 1 even on a white dot. So they add up to an odd total, and yet these 3 add up to 16, so this one is odd. Now my colouring is all over the place. I've got 1 green area, 2 blues that are the same. Oh, and these, yeah, hang on. Didn't we say 5 and 6 have both been used here, and 9 and 4? Right, we are running out of things that yellow can be, I think. And this is probably quite important. Right, let's try this. Even blue is getting narrowed down, but what I said before, and I need to re-emphasize how I know this, I think. This is either 985, in which case that's 6-1, and these two cages use 5 and 6, or this is 976, and that's 5-2, and again the two cages use 5 and 6. So 5 and 6 must be looking at both a yellow cell and a blue cell. Remember, the blues are the same, the yellows are the same as each other. So they can't be 5 or 6. They clearly can't be 4. And they can't be 9, because that 9 is looking at both blue and yellow here. So 4, 5, 6, 9 have been ruled out of all of these cells. And therefore we're selecting from 1, 2, 3, 7 or 8. Now, this is in a 20 cage. So I think we can rule out 1 and 2 straight away. Almost 3, but not quite. If that was a 3, this is an 8, 9 pair. Now, where are we now? Maybe I can't do those. I've got the diagonals to think about. I haven't thought about those at all yet. This trio adds to 16. Oh, maybe we're going to be able to do a sort of secret on the diagonal. This trio adds to 16 without using a 4. I think there are quite a few ways of doing that, so I'm not going to get hung up on that yet. Maybe I don't get any further for now. Now, this adds up to 12. If that was a 7 or 8, we would have used both 7 and 8s here. That doesn't really limit the 12 thing much. This now has 3 possible totals, depending on whether that's 3, 7 or 8, because we know this adds up to 12, and this one adds up to 13. That is 25. These add up to 20, if I'm deducting from 45 correctly. Oh, hang on, this column is interesting. Right, we know the total of this cage is 20, and we know the sum of this line is 16, which I've sort of marked here. That's 36. These two add up to 9. And they're not 4, 5. Oh, and these two add up. Oh, this is better still. If those two add up to 9, remember this is the same digit in both cases, so those two add up to 9. And now we can add the middle row and find out what these two add up to. Those add up to 9, these add up to 7, that's 16, plus the central is 20. This one adds up to 13, that's 33. Take that away from 45, and these two add up to 12. Right, that rules out 8 from these cells, because that would put an 8 there. It's either a 3, 9 or a 7, 5 pair, and this also adds up to 12 now. Can I then add this column? I don't know what red is. Now, this is interesting. If this was a 5, can I make up these totals? No. If that was a 5, this would be 6, 7, and I couldn't put 5 or 6 into this cage. So that is a 9. The yellow cell is a 3. I'm going to get rid of the yellow now. This cage down here added up to 20, and together with the 3, we've got to put 8 and 9 in it. And now we're making actual progress in this puzzle. This is a cage that adds to 9 without using a 3. So it's not 3, 2, 4 or 3, 1, 5, it's 1, 2, 6. And therefore this cage, this set of digits that adds to 16 is 4, 5, 7. I'm leaving that sort of pencil marked 16 total for now. No, I'm not. I'm just going to have to work out every time I want to recalculate this line, I'll add this up. Anyway, 16 there. These two were adding up to 9, I remember, for the column. So it's either, well, it doesn't have a 3 in blue anymore. So it's either a 1, 8 or a 2, 7 sum. Now, what's going on in this row? There must be some digit. Maybe not. That is stuck in one area. No, I don't know. Hang on, we've got 4, 5, 7 down here, so this is not a 2, 7 sum. This is a 1, 8 sum. And now that's a 1, 8 sum, and this is not a 1, 6 pair, and that's not a 5, 8 pair. And we've identified those. We can do this. We can take 5 out of it. Therefore, we also take 8 out, and that's a 9, 7, 6 triple. These are selected from 1, 3, 4, 8. The one on the white dot with a 2 or a 5 won't be an 8. They have 3 and 4 in, so this line's segments add up to either 8, which is not possible, or 15. So why is 8 not possible? Because there are 2 segments in this box, and maybe you can either say you just can't make a total of 16 from 6 digits, or you can't have a 1 in both of those segments. So I'm ruling 1 out of here and putting it in here. Blue has become 1, and yes, I'm going to remove the blue colouring. That digit is an 8 in the central box. This cage is made up of 2, 3, 6, 9. Now, this cage has either a 2 or a 6 in it. It's either a 1, 6 or a 2, 5 pair. And whichever one of those is 2 or 6 can't appear in those cells and must appear here. Oh, I could have much more easily seen why that was 2 or 6. Oh, and now I could start adding up this diagonal. So these add up to 15, so these add up to 15. Plus 4 and 3 is 22. Plus that is either 24 or 28, leaving this to be either 21, which it won't be. Let me just do this again. 15, 18, 22. If that was a 2, that would be 24 for these cells. These would add up to 21. But if those added up to 21, these would add up to 21. That would be 42 for those cells, and these would have to add up to 3. We can't achieve that. So that is not a 2. That is a 6. That's the right answer, isn't it? 15, 18, 22. Yes, 6 is correct. Okay, so that's a 2, 3, 9. Triple. This is not a 2, 5 pair. This digit is 5 or 7 because there's a 2 in the box. It's odd that that's not resolved. That's 2 or 5. It can't be 7 because of those. This is 2, 5 or 7. Now, we know exactly what this total is, finally. 15 there. 13 here. That's 28. This is 17. So this group of cells adds up to 17, plus 22 here is 39. These add up to 6, and that's a 2. And this is now 1, 2, 9, which is fine in that row. This is 4, 5, 8, which does add up to 17. Now that adds up to 17, and that adds up to 17. So this area adds up to 34. So this area, I'm going to give it a colour, adds up to 11. Which I can't even write in 2 pencil marks. 11's quite low, but don't know. Okay, but that's good progress. It's odd that actually because this 5 or 7 thing is still uncertain. I don't know. These have a 4 and an 8 in. So their total is either 17 or 19. So the 6 cell area in this box that has 2 of those is either 34 or 38. And this area, orange grey, is either 7 or 11 as a total. If it was 7, it would be a 1, 2, 4 set. I wonder if this is where Murdoch's puzzle starts getting really difficult. I don't know. I mean, I've had a very enjoyable 15 minutes so far. No, let's think about these totals. This line adds up to 15, and we can't use 6, 4, or 3. This line is not quite so middly. It adds up to 17. Right, which high digits are we going to use there? Not both 9 and 8, because that would bust it. We need to get 17 in 3 digits, not in 2. But not neither 9 and 8, because then they'd both be up here in a 15 line. That's not possible. So one of 9 and 8 in each of these. Right, let's look at this one, which adds up to 15. If that had a 9 in, it couldn't have 4, 2 as well. It would be 1, 5, 9. If it had an 8 in, it would have another pair that added to 7, which couldn't be 6-1 or 3-4. It would be 8-5-2. So this is either 8-5-2 or 1-5-9, and there is a 5 on that bit of the line. And there's no 7 there, so there's a 7 on this bit, and one of the high digits. This is either 7-8-2 or 7-9-1. I mean, that's all correct, and I wish it was a little more helpful, if I'm honest. Well, hang on, this doesn't add up to 11. Sorry, it does add up to 11, and it doesn't have a 7 in it now. I'm just wondering if that means it can't have a 3 in. 3 in this box is actually confined to one of those two cells, which is a bit strange. It's either in a 17 sum here with 9-5 or 8-6, or it's in an 11 sum here with what? With 2-6. Oh, bother. Okay. I mean, I don't want to think about the other diagonal because I just don't know. I don't know what this is. Okay, let's think about this one. I'm going to have to try. Oh, now I've got the white dot as well. And this one. It's still quite a lot to think about, if I'm absolutely honest. Okay, let's think about this line, which adds up to 16, and we can't use 1 or 4. So again, with the big digits, we can't put 9 and 8 on the line. Could we put them both on this bit of the line, which adds up to either... quite big numbers, 19 or 17. If that was, it couldn't be 984, but it could be 982. Oh, rats. Oh, I'm just left not knowing now. Do the white dots clear things up? I don't think they're going to. Oh, I should know what this adds up to. Because that adds up to 15, this adds up to 15, oh, this also adds up to 15. That's not the most helpful of totals. Wow, okay, not sure what I should be looking at. This white dot, so these three add up to 16. And this is a consecutive pair. Yeah, let's think about this. Let's think about this. This is a consecutive pair. It's not 2-3 because that would be an 11. It might be 3-4 and this would be a 9. If it was 4-5, this would be a 7. This might not be worth doing. If it was 5-6, this would be another 5. That's not possible in the same box. If it was 6-7, this would be a 3. And if it was 7-8, this would be a 1. So it's either, well, we're either using, oh, do excuse me, I'm sorry. Right, what I was saying was we're either using a 4 or a 7 here. Can we look at that in conjunction with these white dots? It's difficult. No, I don't know where we're going there. Sorry, this is not, it's just not easy. Should I be thinking about this 13 pair? I doubt it. Okay, let's come back here. We've got 17, 17 and 11 in purple. 17 here. If that was a 3, these are 5, 9 or 6, 8. If that was a 3, these are 2, 6. And then this is 1, 7, 9. And this is 4, 5, 8. Which would give me a 4, 5, 8 triple here. Ah, goodness gracious. I don't know quite what we're meant to look at now. Oh, this can't be a 1 by Sudoku. Not very interesting, that. 15, 15, 15. Actually, what are the 15s up here? That might be worth thinking about, because there are 3 groups of 15. The 9 can go, obviously, with a 5 and a 1 on the line. Could there be a 9, 4, 2? If there was, this would be an 8, 5, 1 line. And the other line would be 3, 6, 7. That's not right. That's not adding up to 15, so I've got something wrong there. 9, 4, 2 is a 15 line. Nine, 4, 2. That would make this line impossible. We'd only have left 1, 5, 8. That doesn't add up to 15. Right. There cannot be a 9, 4, 2 line in this box. So wherever 9 is, it goes with 5 and 1. And it might be on this diagonal, but it might... Yes, it must be on this diagonal, because 5 is on this diagonal. Right. That's weird. That's not a deduction I was expecting, a form of it I was expecting to make, but it does work. 9 can't be with 4 and 2, or this diagonal couldn't work in this box. So 9 must be with 5 and 1, and 5's on this diagonal, so that's what it is. So this is a 2, 7, 8 diagonal now, down here. Well, that's changed things a bit. Now, 1, 5, 9 here, so let's take 8. 8 goes either in that group of 15 or in this group, and it goes with a pair that is 4, 3. It can't go with 1, 6 or 2, 5. So it's either 3, 4, 8 here or here, and the other group is 2, 6, 7. Okay, this digit can't be 3. It's even, because that's now odd. Isn't that strange? We know its polarity, just like we know the polarity of this one. And that's even. So this is an odd pair to add up to 15 in all of these dark greens. If that was a 2, these add up to 13. Wow, this is such a strange part. Oh, there's an X-wing on 1s. Those 2 have a 1 in. Those 2 have a 1 in. That's going to use up the 1s in rows 1 and 2. The 1 in row 3 is in one of these cells and not on the diagonal where there's already a 1. So the 1 in row 3 is in one of those cells. And this grey area, I can't even remember. Oh, we don't know what it adds up to. It was either 7 or 11. Oh, there's some seriously weird thinking to do here. Now, if that's a 1, this is a 2. If that's a 1, this is 6. So this digit can never be 6. Such a strange conclusion again. I don't know what I was expecting here, but it's just not happening, whatever it was I was expecting. Now, this pair adds up to an odd number. So there's 1 odd and 1 even there. This pair obviously has 1 odd and 1 even. That is odd. That is odd. That's 4 of the odds. In the column. That's quite interesting, isn't it? Maybe not. These both have even and odd options. Oh, I don't know how we're meant to be making progress. If you can see something obvious, shout it out. Maybe I'll hear you. These add up to 7 or 11. Unfortunately, those are both eased by having a 1 in, not made more difficult. This is 278. Okay, down in this box, we've got a 17, and an 11. 11 now cannot have the 3 in because it was going to have to be 326. It can't be 317 or 326. That 3 is not in the 11 segment, it's here. In the 17 segment, these two add up to 14 without using an 8. They're a 5-9 pair. Right, we may have got going. This is a 146 triple in the pinky purple. Now, what does that do, if anything at all? I know you're going to say it does nothing at all. Right, I was nearly considering where do 5 and 9 go in this column, because I've got that 5-9 pair looking at that cell. And these can't be 5 or 9. But that could be a 9, and one of these could be a 5. That's frustrating. Oh, 3 can't be here anymore by Sudoku now. 3 is in one of these 3 cells. Now, if it was on the diagonal, what does the diagonal add up to here? The same as this, 16. The other 2 digits on the diagonal would add up to 13 without using a 4. So we would have either 358 or 367. 358 would make this pair 6-7, and 367 would make this pair 4-5. But we don't know that 3 is on the diagonal. 3 could be in one of these cells, and that's frustrating. Okay, if that's a 2, this pair adds to 13 and has to be 6-7. If that's a 4, this pair adds to 11, can't be 4, 7, 5, 6 or 9, 2, and would be 8, 3. And that would be 4 in that case. This would have to be 6, 7. If this is an 8, these two add to 7. And they're not 1, 6 or 2, 5. Then they're 3, 4. And again, there's a 3, 4, 8 triple. Right, something has just happened in this column. And it is about 6, 7. Either this is a 2 and 6, 7 go together here. Or, if this is 4 or 8, we get this 3, 4, 8 triple, which means 6, 7 go together here. So in column 7, 6, 7 is either a pair down there or up here. And in either case, this, and indeed this, can't be 6 or 7. But for this cell, it's conclusive. It makes it a 9. And that makes this a 5. And that's quite an interesting deduction, honestly. This is now extreme. And that is not 4. So this is either 6, 7 or 4, 3. And this, if that's 3, 4, this is 6, 7. And if that's 4, 3, sorry, if this is 6, 7, this no longer has a 5 in since we got that 5. So this can't be 4. Then this would be 4, 3. So this only has, I don't think 8 can be here anymore. If this was 7, 8, this couldn't be 4, 3 or that would be broken. And it couldn't be 6, 7. So 8 is not here. This is either a 6, 7 pair or 4 and 3. And this is therefore, I've forgotten the total, 7. This is either a 9 or a 3. Now, this is extreme. This is either a 1, 2 pair or a 9, 8 pair. If it's a 9, 8 pair, that's 3, 4, 5. Okay, if it's a 1, 2 pair, that's 5, 4, Oh, how can that not do anything? That's so annoying. Right. This is, well, we have a 3, 4, 6, 7 quad in the column. This was the same as the 6, 7 thing. So that's now an 8. And there's only one place for 2, and that's here. That's weird. Weird, weird puzzle. Absolutely freaking me out a bit now. 2 on the diagonal, and this diagonal adds up to, still have to remind myself, 16. These two add up to 14. They don't have a 3 on. They're either 6, 8 or 5, 9. How can I not know which one? If they're 6, 8, this is 4, 3, 9, and this is 1, 5, 7. If they're 5, 9, this is 3, 6, 7, and this is 1, 4, 8. I can't decide between those. Oh! Right, how about this diagonal then? We've had a 2 on it, and this group, oh, I don't know, that's not what we wanted. Because we don't need, oh no, we did want that 5, because now we know that red is 7. That's absolutely what we wanted. Goodness me, so that's a 5. Yes. Right, so now we do know the total of this line. That's going to help. Oh no, yeah, well, it's got the other pair from 5, 9 or 6, 8, and it's got a 3 on it. There's only one place for that 3 to be, because 3 is the only digit I've actually placed in boxes 4 and 7. So that digit becomes a 3. These two can't be 3s. That can't be 4 anymore. What's this doing now? I mean, this is so confusing. These are either a 5, 9 or a 6, 8 pair. This line, though, now definitely adds up to, it's the lower number, 17. So that adds up to 17. And this grey area adds up to 11 now. 1, 2, 8 is possible, or 1, 4, 6. Again, there's parity. Every other digit apart from the 1 is even. Oh, well, if we're going to use an even digit that's either 8 or 6 there, this can't be a 6, 8 pair. Good. Good. Good old parity. I knew it would do something. That's 3, 5, 9. So that we take out 5, 9 from these cells. These are a 6, 8 pair. And now we know where the 6, 7 in this column are that got us going. That's a 4, 3, 9 triple. Let's get rid of the colouring. All of this colouring. That's a 6, 7 pair. And therefore we know that, well, I got rid of the colouring, but we remember that this group of cells added to 15, so that's a 2. And that sorts out the white dot and something else in this column. It makes this a 5, that's a 4, that's a 3 now. We're not going to get a 3 in any corners. That's 3, and this is a 4, 8 pair. There's probably a way of doing, that 5 is looking at this cell, isn't it? Good. This is just Sudoku now. That's back in my comfort zone slightly from complicated thoughts that we've been having to have otherwise. 6 and 1. Oh, there really is a lot of Sudoku to do. Hurrah. I dare say you'll have spotted something I was missing earlier, because that is the nature of the beast, isn't it? But I can't see everything that you see all at the same time. Somebody very ungenerous the other day saying, you really are bad at looking at scanning. Well, if you happen to see something that I'm not looking at, yes, I will look bad at scanning. I don't feel bad. Now, there's something going on here. Is it 5? Yes, it is 5. There's only one place for 5 in that column, and it's there. And that's because I should have sorted this 5, 9 pair a moment ago. Now that 9 is placed there. Lots of odd digits getting actually placed in these 3 columns. Oh, 4, 8 pair looking at the corner. That's good. 6, 8, 6, 7. That's a 7. This is a 1, 5 pair. We know the order. We don't need any of these colours. We don't need any of those colours. I'm still remembering that these add up to 11, and it might help. 4, 6, 8. Come on. Can't do those. Oh, can't even write in the correct digits. Sorry. 2, 1 there. These I can do, 7 and 5. That lets me do 2 and 7 here. That comes back and does 2 and 1. That makes this a 6. This is a 9. That's an 8. 1 and 4 still to place down there. Good. That 4, 8 pair is not resolved. These add up to 11. Oh no, let's just do the first column. 6 there. 6 in this box is now definitely here. And that's not going to be an 8 if they add up to 11. This is not allowed to be a 3, so it must be a 1, and that's a 4. As long as my maths is right, these will be 7, 8, 2, which is a segment adding to 17, which is the total we wanted. Good. Excellent. And there we go. What a lovely puzzle by Murdoch again. And what an intriguing double-parted solve. Oh, I was worried why I didn't get the tick there. There we go. Congratulations. I want to thank Math Guy 12 for the inspiration to this puzzle. I was showing his puzzle Difference of Squares to a friend, and that led me to this idea for a puzzle. I do remember that. We featured that on the channel. It was very, very good. And there we go. We have factored in the difference. I don't quite know what the title meant. I mean, we obviously used factors to some extent at the beginning and differences constantly. And it's a very good puzzle, very clever. I love the symmetrical blue shapes, and some easy algebra at the beginning for once. Let's see what we get tomorrow. Do join me again. A pleasure being with you as always. Bye for now.